Hello students, let's try to solve some more problems from the subject linear algebra. Our first question is three non-zero coplanar vectors are linearly independent, linearly dependent, neither dependent or independent, or none of these. The correct answer for this question is these vectors are linearly independent. The coplanarity of three vector is defined when their scalar product is 0. That's why you can easily check it out that these vectors are linearly independent. Next question is, if a subset S alpha 1 to alpha n of a vector space Vf is linearly independent, then any vector of S is not a zero vector. Every vector of S is a zero vector. At least one vector of S may be 0 or none of these. The correct answer for this question is any vector of S is not a zero vector, because if it will be 0, then we could not find out the value of coefficient as a 0. That's why the condition 1 is true. Next question is the vectors 1 2 minus 3, 1 3 minus 3 2, and 2 1 minus 5 are. To check the linear dependence or linearly independence of these vectors, we have to write these vectors as a linear combination of a 1 2 minus 3 plus b, or a2 you can write it as 1 minus 3 2 and plus c 2 1 minus 5 equals to 0. When we solve these three terms, then we have a equals to 0, b equals to 0, and this c is also equals to 0. That's why these vectors are linearly independent. Next question is, the intersection of two linearly independent subset of a vector space will always be linearly independent. Next question is, any set of vectors containing a zero vector as a member of linearly, it will be dependent, because if we have a condition a alpha equals to 0 and this alpha is 0, then we can't say a may or may not be 0. That's why this is a linearly dependent set. Next question is the subset. This is the standard basis for the vector space R3 and it is linearly independent. You can easily prove it out as a1 into 1 0 0 plus a2 0 1 0 plus a3 0 0 1 equals to 0. It will come out as a1 comma a2 comma a3 equals to 0 vector. This simply means a1 equals to 0, a2 equals to 0, and a3 equals to 0. That means this set is linearly independent. Next question is, the vector space V3R is of dimension 3, because the standard basis for this V3 dimension have 3 number of elements and its form will be 1 0 0 0 1 1 0 1 0 and 0 0 1. Its standard basis will have 3 elements. That's why the dimension of this V3R will be 3. Next question is, let V be a vector space of 2 by 2 matrices over the field F. Then the dimension of F is, it will be 4, because for this matrix the standard basis will be, we have 4 matrices 1 0 0 0. This will be your one matrix. Then 0 1 0 0 0 0 1 0, and fourth one is 0 0 0 and 1. That's why the dimension of this V will be 4. In general, if we have a matrix of the order m by n, then the dimension of that matrix, that vector V, will be m into n. Next question is, the dimension of the vector space C2R will be 4, because the standard basis for this will be 1 0 0 1 iota comma 0 and 0 comma iota. That's why we have the dimension of this C2R will be 4. The last question is the dimension of vector space CR will be 2. The standard basis for this will be 1 and iota. That's why we have the dimension of this vector space CR will be 2.